Hey guys, in this video we're going to be learning how to graph horizontal and vertical lines. So we've learned how to deal with the basics of slope and y-intercept and all those, the basics of graphing a slope-intercept equation. Okay, horizontal and vertical lines, right, are a little bit different. So I'm actually going to show you how to do this first in Desmos, and then I will do some examples with you on the boards here. So Desmos first, then examples.
Okay guys, we're here in Desmos and I just want to show you guys real quick what happens when we graph horizontal and vertical lines. So just ignore the equation part for now, I'll explain that later on. But like for example, this is going to be the graph of a vertical line, right? It's going straight up and down, right? And that's different from a lot of the other lines that we graph, like if I did y equals 2x minus 5, right? This would be a normal graph that we looked at, right, with a slope and a y-intercept, right? But horizontal and vertical lines are a little bit different. They kind of break the rules a little bit from the other lines that we've graphed, right? So they don't necessarily have the same y equals mx plus b form with the equations, but what I want you to just notice about this one is the equation is x equals 4, and when the equation is x equals a number, notice that this red line only touches the x-axis, right? It only touches the x-axis and it never crosses over this y-axis, right? Even when I zoom out, it's going to stay completely vertical that whole time. Okay, so that's what's true about vertical lines. Okay, and I can even adjust what the x value is, right? And as long as it's just x equals a number, it's just going to be whatever that spot is on the x-axis. It's going to cross through there, and it's just going to be a completely vertical, straight up and down line. Okay, now compare that with if I do like y equals 4. Okay, it's just the opposite, where it's a horizontal line going side to side, and again, as I zoom out, you see it doesn't curve at all in any direction. It just stays a horizontal line. But like with this one, right, it highlights the point here, 0 comma 4 for us, and it only crosses through this y-axis. Okay, yeah, on the y-axis here it touches at 0 comma 4, and it never ever crosses down through this x-axis. Okay, so that's something helpful to remember, is when it's a y equals a number equation, it only touches the y-axis, and if it's x equals a number equation, it only touches the x-axis.
Okay, so there's some acronyms that can be helpful to remember. HOY, H-O-Y, and VUX, V-U-X. Okay, so let me talk about what these mean because they can be helpful to you as you learn how to do these types of lines. Okay, so HOY. Okay, HOY is going to be applied to number 2. Okay, HOY. HOY. HOY, the H stands for horizontal. Okay, so when it's a y equals equation, right, and that's what the y in HOY stands for, y equals a number. It's just a y equals -3, y equals 0, y equals 8, y equals just a single number. It's going to be a straight horizontal line, okay, side to side, okay. But then the O in HOY, the O is actually a 0, okay, because you see the M says 0 slope, and I'll talk a little bit more about that when we graph number 2 here, okay. Whereas the other one is going to be applied to number 1. That's VUX, V-U-X. Okay, VUX. So the V stands for vertical. Okay, and the X is obviously the same thing. X equals a number. So when it's X equals 7 or X equals 1 or X equals -8 or whatever, X equals a single number, it's going to be a vertical line going through that spot on the X-axis. And the U talks about what type of slope that has. And we're going to call that number undefined. Okay, and again, I'll explain more what that means later on, but undefined is the type of slope that has. Okay, so let's graph these guys, and then I'll talk more about these things. Okay, so why this acronym is helpful though is that when you see it's like x equals something, okay, x equals a number, you see that, okay, this is not going to be a normal equation that has like a slope and a y-intercept. So when you see that the equation's a little different, right, and these equations are a lot simpler than the slope-intercept equations, you kind of throw the slope and the y-intercept out the window, and you just say, okay, that's either going to be horizontal or vertical. And that's where these acronyms come in, right? Because you think VUX, okay, so it's x equals 7. If it's x equals a number, that's going to be a vertical line, VUX. Okay, so x equals a number equals a vertical line. So you know it's going to be straight up and down. Okay, and it goes straight up and down right at x is 7. So that's what you do. You go to the x-axis, you go to x is 7, which will be right here, and you just draw a vertical line there. And that is it. Write all these values in here. Right, the x value is always going to be 7. Okay, so like 7 comma 1, 7 comma 2, 7 comma 3. The x value is always 7. Okay, and the slope being undefined. Let me do this one first, and then I'll go back to that. Okay, y equals -3. Okay, again, so when you see that it's just y equals just a single number, not y equals like the whole mx plus b, you say, okay, y equals a number. That is a horizontal line, right? That's why this acronym can be helpful. HOI. Y equals a number. It's a horizontal line, so side to side. Okay, and I do the same thing. I go to the y-axis. I go to -3. So y-axis, go to -3, and I draw a horizontal line there, right? So this is never going to touch the x-axis, okay? And that's my line. That's the whole thing. And the slope is 0, okay? Now, what's the difference between these slopes? Now, let's talk about that. Let's actually bring back our rise and run thinking here, okay? So let's for this one, just sketch a couple more points, like I said. And let's think about what the rise and run would be for this, okay? So if I start here, and I think, okay, how much is it moving to get to the next point? Well, I would think, okay, up and down first, right? Because that's rise. So I would think, okay, it's going up 1, and then how much is moving side to side for the run? Well, it's not moving side to side at all, right? It's just going up 1, and that's my point. So I'd say up 1 over 0. So that's what the slope of this line would be. And you might be thinking, okay, well then what's undefined? What does that mean? Okay, that's not really like a number. And it's not, right? Because if you think about this, 1 over 0, right, as a fraction, 1 divided by 0, if you did that in a calculator, 1 divided by 0, or anything divided by 0, you would get an error. It would say, error, you can't do it. Because that's one of those math things that is not possible. You can't divide by 0. In fact, if you wanted to see something, I would show you, but my phone is recording. But so when you ask Siri, what's 0 divided by 0, she gives a funny answer. So maybe try that yourself. Yeah, you can't divide something by 0. That's why this is undefined. Okay, so it's a non-definable number. We can't say what the slope is because you can't do something divided by 0. Now compare that, because it's going to be really similar to what the slope is for this one. And this slope is not undefined. It is a 0 slope. So what does that mean? Well, we think about the rise and run here, right? If I do the same thing, draw a couple points, I think, okay, well, how much is it moving to get to the next one? Well, I would say, okay, rise, how much is moving up or down? Well, it's not rising at all, right? It's just I'm going over 1. And that would be like a run. I'm moving right 1. So I would say 0, the rise of 0, because it's not moving up or down, over 1 would be this slope, okay? But if you did 0 divided by 1 in a calculator, that is possible. 0 divided by 1 would just be 0, okay? Compared to this one, where the 0 is on the bottom, that's not possible. But 0 on the top, yes, you can do 0 divided by anything is just 0. That's possible, and that's why we say 0 slope for this one. Okay, and that's what the O and the U stand for in these two problems. Okay, so I hope that makes sense. We're just going to do a couple more examples, maybe a little bit more complicated, and that'll be it. All right. Alrighty, so I've got 2 more examples up here. And you notice I expanded the directions a little bit. I'm saying graph the linear equations, which is what we did last time, and give the slope and the x and y intercepts of each line. So it's asking us some information about each line after we graph it, okay? But let's graph them first, okay? So number 3 here, y equals 5. Y equals 5. So what does that mean? Well, that means I'm going to go to positive 5 on my y-axis. Okay, positive 5 on my y-axis. I'll make a point there. That's where you start. And then again, this is where it's helpful. Is this going to be a horizontal line or a vertical line? Okay, again, this is where it's helpful to remember the acronym HOI. Okay, HOI, H-O-I. If it's a y equals equation, it's going to be a horizontal line or side to side. And again, if you also remember that a y equals equation is never going to touch the x-axis. So if it was a vertical line, it would touch the x-axis. A couple ways to remember that. All right. And then also with this acronym, right? So it's a horizontal line. So y equals just a single number equation. And then this O, remember, O stands for zero slope, right? Zero slope. So when it asks for what's the slope of this, we can just say 0, right? Because that is true of all horizontal lines. And now x-intercept and y-intercept. Again, what do those mean? X-intercept is where is this line touching the x-axis, and then y-intercept would be where is this line touching the y-axis. X-intercepts. Okay, so I'm thinking, where does this line touch the x-axis? And it doesn't, right? It never touches it. So I would say none. There are no x-intercepts for this line, right? There are no places where this purple line or maroon or whatever color this is touches the x-axis. Okay. Then the y-intercept. Where does my line, purple, magenta, whatever, where does this touch the y-axis? And that happens right here at. Now I can't just say 5. That is where it touches it, but I want to give it as a point 0, 5. That would be the point where it touches the y-axis. Okay. Now number 4, same thing. So I'm given x equals -1, and I'm asked for all this extra stuff. I'll do it a nice sky blue for this one. X equals -1. So again, I start by going to -1 on my x-axis. So -1 on the x-axis would be right here. And again, I'm wondering, do I draw a horizontal or a vertical line? And again, that's where VUX can come in, VUX. So if it's an x equals equation, it's going to be a vertical line, straight up and down. So that's what that line looks like. So I graphed it. Okay, now I want to give this information. Okay, also from this acronym, right? If it's x equals equation, it's vertical, but it also has U. What's the U stand for? Undefined. That's that word that means it's something over 0, which means it's a number that we can't define, or it's an undefined slope. And then these last two, the intercepts, okay, I'm wondering where does it touch the x-axis, okay? Or what's the x-intercept? And again, that happens right here, that point, right, that I drew originally. And so that the coordinates of that would be -1, 0. And then the y-intercept, where does it touch the y-axis? That would be none. Cool. I think I'll do one more here and then we'll wrap up. Okay, so I got one more up here, number 5, y equals 0. Okay, and I realized I wanted to go over this just because there is a little bit of special stuff that happens with this. Okay, so y equals 0, let's think about that. Okay, so again, I would go to 0 on my y-axis, and where is that? Well, that happens to be just right where my origin is, right? So this can be tricky because, right, we kind of have the axes right there, the x and y axis, and we're wondering, where would this go? What would this line look like? And again, that's why it's always helpful to remember your acronym. HOI, right? It's a y equals equation, so it's going to be horizontal, side to side. It's basically, this line is basically the exact same thing as the x-axis, which is a little bit weird, but that's what this line does look like, y equals 0. Okay, and I'm wondering what the slope in this information is. Okay, so again, it's a horizontal line with a 0 slope. So the slope is still 0 for this, just like before. I'm going to skip x-intercept because that's going to be interesting. Y-intercept, again, it's just where it touches the y-axis, and that would, again, be at the point that I drew originally, 0, 0. Now, x-intercept, okay, x-intercept. This one's interesting because this line is basically the x-axis, right? So if I'm wondering, where does this line touch the x-axis? It's always touching the x-axis, right? Usually this would be none, like no, it doesn't usually cross, but this is the one circumstance where, yes, it does touch the x-axis because it's basically the same as that. So for this, I would not put none, okay? I would actually put the answer that means everything in math, all real numbers. That's my way of saying always, every single time. All right, for in terms of x-intercept, every single point technically is an x-intercept because it's touching the x-axis the whole time. Okay, so I would put that all real numbers answer for that. Okay, that's the only real special one for these that you run into. But I hope that makes sense. That's a little bit on horizontal and vertical lines. Okay, we're going to keep chugging along here through graph and lines. You're doing great. So thanks for watching. Good job.